Number 10, the measure of angle BAC is greater than the measure of angle DGE. Number 12, segment SR is greater than the measure of segment XY. Number 14, the measure of segment PS is less than the measure of segment SR. Okay. Number 16A, Joel, because of a big old long explanation, what they said is Pedro turned 15 degrees south, so the measure of the angle across from the side of the triangle that represents his distance from the camp is 180 minus 15, or 165. Joel turned 35 degrees north, so the measure of the angle across from the side of the triangle that represents the distance from the camp is 180 minus 35, or 145. And then by the Hinge theorem, since 145 is less than 165, Joel is closer to the camp. 16B is also Joel, because pretty similar explanation. We need more than that. We will take that question when you ask it. Number 18 is negative 4.5 is less than x is less than 33. Number 20 is x is greater than 7. Number 22 is Sean, because that's my name. No, just kidding. Since the lengths of the openings of the lockers and the lengths of the door of the lockers are equal, you would use the converse of the Hinge theorem to determine that since 17 inches is greater than 12 inches, the angle of the opening of Sean's locker is greater than the angle of opening of Neva's. Neva's? I don't know. And then 24 and 26 are proofs, so we can take questions if you have them. I'm going to hand you some papers. Number 10. What's your question on number 10?
How is BAC bigger than DGE even though the length of DGE is longer than BAC?
Well, let me finish handing out these papers and I'll answer it. Excuse me. Okay, so on number 10, it is ACB, which has 6, 4, 3, and EDG, or something like that, yeah. EDG, which has 6, 5, 3, and we're supposed to compare the measure of angle BAC and the measure of angle DGE.
Which I said that DGE is greater, but you said BAC is greater.
No, BAC is less than. That's what the key says.
Oh, I give you.
Oh, not on the question.
Oh, okay, good.
Because I heard BAC.
Who knows what I said out loud? We'd have to roll back the tape, which is possible, but yeah, BAC is less. What's up, bro? 634 and 635, yeah. Yeah, this one's less. Because of the Hinge theorem. What other questions from this lesson do we have? Which one? 20. Sure thing, boss. Yeah, we should definitely do 20. I was telling y'all the other day that that it is very probable that we have a problem just like that on the test. Or at least a lot like it anyway. Oop, didn't mean to attack you. Just kind of happened. Excuse me. Number 20. We've got this attached to this. And this side is 5x, and this side is 5x. This side is 5x plus 3. And this is 60 degrees, yes. And this is 95 degrees. And this is 3x plus 17. Okay, and we're supposed to find the range of possible values for x. So, what should we do? And why should we do it?
What I did was I found the measure of the angle opposite to 3x plus 17.
You're talking about this little angle right here?
Yeah.
How'd you do that?
We're given that the bottom right corner is a 90, so that means the inside of it.
Yeah,
At least in our picture.
that's what I was.
Oh yeah, here you are.
And so the inside is 30 in subtraction.
So you said this is 30 for some reason, and then you also figured out what this was, 125 minus 180, absolute value, or you just 180 minus 125. Either way it'll work, which will give us what?
55.
55 degrees. That's true. I don't know why we did that, but you could.
So I knew that 5x plus 3 is bigger than.
Oh, you're right. That is why we did it. Okay, so I was being real snarky in that problem. You do need to do that. He's right. That is what we need to do, because we need to be able to use the hinge here. We got to be able to figure out which one of these, is it this one or this one that's bigger, right? Because we're given just the 95 degrees and the 60 degrees. We need the one opposite it, right? And so we need to figure out what this is. So since this is 90, 90 minus 60 is 30, right? And then 180 minus 95 minus 30 is 55. So now we can see that this one is going to be bigger than that one, right? Because that's what how the hinge theorem works. And we know the sides work fine because this one's the same as this one, and then these two are the same because reflexive property, right? So the hinge theorem is applicable. So now what?
5x plus 30 is greater than 3x plus 17.
Sounds good. Five x plus 3 is greater than 3x plus 17. Now what? More specifically.
2x is greater than.
Yeah, how'd you do that? What'd you do?
Yeah.
No, we subtracted 3x. Combining like terms is for on the same side, yeah?
I meant, yeah.
I know. I'm just correcting your vocabulary. You did it both did it perfectly. We're just going to use the right words, right? So 2x is greater than 14. Now what?
Divided by 2.
Divide by 2. So x has got to be greater than 7.
Wait, that's the answer.
Mm-hmm.
We don't have to do more to find something that x has to be less than.
Yeah, that's what.
What would we have to do, and how would that work in this problem?
3x plus 17 is greater than 5x.
But that's not a true statement.
It is. Because 3x plus 17 is opposite to 55 degrees, where 5x is opposite to 30 degrees.
5x plus 3 is opposite to 60 degrees.
Or 55.
Oh, you mean the...
Yeah, 55, but it's still larger than 30, so it doesn't matter.
Oh, I thought you meant... Oh, so 5x, not the 5x plus 3.
No, yeah, 5x was what he was talking about. He was talking about those.
But isn't this work on 2 triangles, not just 1?
How does this work if 5x is larger than 30 and 5x plus 3 is larger than 60?
Pythagorean.
So do we need to do it or not?
Not on this problem.
So how do we know when we have to have something that x has to be less?
Let's do what you said to do. So what would we have to do? Let's start with that.
3x plus 17 is greater than 5x.
Okay. What now?
17 is greater than 2x.
Okay. So you subtracted the 3x. You got 17 is greater than 2x.
And then divided it by 2, and 8.5 is greater than x.
So x less than 8.5.
But is this the Hinge theorem?
What? No, it's not the Hinge theorem, not really. Triangle inequality theorem is what he's, because you're using a single triangle, yeah? Right? Yeah. So it's theorem from lesson ago. That's where he got that from. If the, let me remind you what the theorem says, and then I'll show you where we're different. Hinge theorem is for 2 triangles, right? The reason we got this equation is because 55 is greater than 30 for one triangle. We didn't need this triangle at all. So it's the same idea, it's just for one triangle.
Yeah, I see that.
Oh, okay. Well, I didn't understand where your confusion face was coming from. What? Trying to decide whether we're wrong or whether the key is wrong, because the key only has this one. There's definitely not an infinite number of values that x could be. Or is there? Or is there?
Well, it doesn't make sense because...
It does, actually.
Because there's no solution.
But go ahead, say what you're saying.
Wait, never mind.
What were you
I
thinking?
was thinking that the degree of the angle was constant with the length of the side, but it's not.
Mm-mm.
It just means
So on this particular problem, we don't need an other side. What's different about this one?
We don't have any.
We don't have any of the sides? Well, yeah, actually, kind of. That your wording is weird, but kind of. Yeah, what do you... see if we can put some other words onto it.
All the sides of a variable.
All the sides of a variable. So we can keep on getting, as long as it's bigger than 7, just stretch it out forever, right? And then it just keeps on going because they all have an unknown in them. If they didn't, if one of them was fixed, then there would be only a range. But this, on this particular problem, since they've all got variables, we can keep on stretching it forever, as long as it's at least 7. I bet so. Is that one of the proofs? Yeah. It's the longer one. Good job. at least according to the key, anyway. We shall find out what we shall find out. Anybody doing anything fun and different for Thanksgiving? People tend to do the same thing over and over again for Thanksgiving. Anybody trying a new recipe this year? Anybody's mom forcing you to try a new recipe this year? Sometimes moms are like that. Like, I want to try this casserole recipe. It's going to be delicious. And sometimes it is. And sometimes it's not. And sometimes you're like, Mom, quit messing with the thing that we all like. Do the one that we like. If you want to try it, that is my rule personally for like doing like holiday meal stuff. I love trying new recipes. Trying new recipes is great. And don't try a new recipe for the thing that the recipe already works well. Do a whole new thing. Like if everybody has a green bean casserole recipe that they love, don't try a new green bean casserole. Try some other vegetable side with the green bean casserole. Don't mess with the thing that's already working. Green bean casserole is what?
Green bean casserole sounds weird.
If you never had a green bean casserole, that's a pretty common southerny thing. I like green bean casserole. I didn't used to when I was a kid, but I quite. Broccoli casserole can be really good. I like a broccoli and cheese casserole. It's pretty good.
I always am the one that makes it.
Nice.
Extra cheesy.
Nice.
I'm just gonna buy a whole pumpkin pie and sit in the room and eat it by myself.
Are you gonna be thankful for that pumpkin pie?
Yeah.
Then I think you've accomplished the meaning of Thanksgiving.
Yeah.
Well, sort of. But yeah. We'll go with it. That's funny.
I mean, look at her. The poor kid only has so many things to be grateful for.
I know. There's only so many Warrior Cats books in the world.
Oh, so beef.
Not trying any different casseroles. I'm gonna serve the Runners Club Turkey Trot.
Nice. That sounds fun.
I've never done it before. We have the service every year. It's better for me.
I'm
Nice.
pretty sure Thanksgiving is almost just like pre-Christmas.
Yeah, that's what I'm saying.
The halftime show. 'cause
That's-
December is the Christmas.
That's what I'm saying. I've been saying that for a long time.
Just a preparation for
I don't know if preparation is right, but it's like,
yeah, not preparation. It's just
what?
Thanksgiving is just like Jacob said, it's halftime show, but it's pre-game show.
Yeah, but it's like better than real pre-game shows. Thanksgiving's great. It's a great part of the holiday season. So's New Year's. New Year's is a nice cap to the whole thing. It's all good. It's all fun. All fraught with nice, fun traditions and all kinds of stuff. Measure of SRV is equal, no, I'm just kidding, LOL, JK, is greater than the measure of angle QRT. And finally, wow, lots of givens. R is mid, brah. Midpoint of segment SQ. And we're supposed to prove That something is something. Segment WS, measure of WS is greater than the measure of WQ.
How many steps long is it as in the book?
In the book, it's 11 steps, including the given. What?
I did it with 7 steps.
What?
I mean 6 steps.
Okay. Where should we start? Remember, if you're like, I don't even know where to start with, does the given tell us anything that hasn't been written yet?
Yes.
Yes.
RS and QR are congruent.
Yes. It does tell us that. Well, it tells us their measures are equal, but yes. Yes.
Oh, wait. That's how I got so many.
The measure of QR equals the measure of RS. And what tells us that? Definition of midpoint. Great, grand, glorious. Now what?
Now we can say that S-V is greater than QT because they're angles, because the SRV is greater than QRT.
Isn't that just the hinge there?
That's the hinge theorem.
Potentially, let's see. Let me kind of do some colors and figure out what you're saying. So we know, let me see if I can kind of mark this. SRV, this is greater than QRT. This one is less than, I don't know, that's not very great marks, but
How'd you get angle S? Isn't it
S, oh, yep, I labeled in the wrong place, thank you. That's what I meant. So this is greater than this, and so you're saying we can say that SV is greater than QT, which we can do because of what we just said in Hinge theorem. Yes, that's totally fine. Okay, so number 3. The measure of SV is greater than the measure of QT because Hinge theorem, true facts.
And then I converted the WV and WT to equals for congruence. I don't know why I did that.
Not either. Do we need to do that?
Yeah, we do, because we're gonna add.
See, where are we, let me kind of label in a different color what where we're even headed. WS, okay, so this one and that one, and this one should be greater than this one. Those are not official marks, but like, we understand what I'm trying to say in my notating to ourselves. So we're trying to get to the big boy. And you're saying what now?
WV is equal to, the measure of WV is equal to the measure of WT because the definition of congruence.
Yes, turning these into the equals. Okay, great, fine, sounds good, let's do it. For the measure of WV equals the measure of WT, that's turning this into equals, right? Because definition of congruent segments. Great. Now what?
Now can we say WV is equal to WV through substitution? And then after that, we can say W.
Where are we substituting?
So, oh, I know we'd have to say it's equal to itself. So, I was thinking we would go down the route of, since they're equal, we'd use one of them plus SV is greater than QT plus one of them, and then we simplify that. to get to the, what we're trying to prove, would we have to say it's equal to itself before
I don't know what would let us say that. I mean, it's reflexive, like, okay, so saying this is congruent to itself, what does that accomplish? I don't understand what you're.
So we could use substitution, is what I was saying.
So instead of doing WT plus TQ and WV plus SV, you could just do WV plus SV is greater than WV plus QT.
I think we're putting the cart a little bit before the horse. Shouldn't we do segment addition first?
That's what I was trying to do.
Segment addition.
Yeah, because we know something about this, we know something about this, we know something about, so we could.
I thought we had to do the other stuff before we could say that.
No, segment addition is just segment like this plus this equals this, right?
Oh. Yeah.
Right? Because then we have some expressions that have everything, and then we could probably substitute, which I think is basically where you're going, where you're headed. But let's get something that we can substitute into first, right? So this plus this equals that, right? So, and we'll do the other side too, in the same thing. So the measure of WV plus the measure of VS equals the measure of WS and the measure of WT plus the measure of TQ equals the measure of WQ because of segment addition. Right? Because now we've got stuff that we have up here. Well, not that, but we already did stuff with that, I think. I don't know. Yeah, we did, because that just gave us Hinge theorem possibility, right? So we've got stuff from up here, and we've got stuff from over here in our proof, right? Again, so I probably have said this before, but the more I reiterate these things, the better we can understand what's happening. So kind of two places that your brain can go is at the beginning, does my given tell me anything that isn't written, which it did in this particular one, and then how can I get everything I'm trying to prove and everything I have in there somewhere? Segment addition, angle addition, and linear pair, like supplement theorem, I don't know, something that lets me get the stuff that I want on the board, right? Or on the paper, which we have now. Now what could we do? I have to do a lot of substituting, is that what you said? Yeah, pretty much. So what can we do?
I don't know where to go.
Let's see. Got the VS. WS. What all do we have with WS? Just the one thing. Okay, great. Okay, I think I see what we're doing. Okay, so somebody tell me something we can think about or do.
Do we have to add the WV and WT into the inequality?
Do we have to add that? Yeah, we're going to have to get them in there somewhere. Somehow.
So can we not just add them in? Since we already know that we equal to each other, can we put them on both sides?
Yeah, kind of. Try to think about what property that would be. It'd be.
Because it would be like x is greater than y, so z plus x is greater than z plus y.
Yeah. We need we need to be able to get WS right here and WQ right there. That's what we need to be able to do.
How do we add in the WV and WT? Like, I don't know a theorem for that.
Well, this is not what the book it says to do. I was thinking we could basically solve this one for measure of VS and solve this one for the measure of QT. And then do some substitution.
So, we know that WT and WV are congruent, and we already have that QT is less than SV/VS.
True.
It feels like it's already there.
It is really close. We just got to figure out what theorems let us rearrange it to make it work. So,
On the test, would you accept if in the side I put like an equation of variables?
an equation of variables? Potentially. So what you're wanting is like addition property of equality. So let's do it your way and we'll roll with that, which is different than what I was thinking, but I think it'll work. So measure of SV plus the measure of WV is greater than the measure of QT plus the measure of WV, because addition property of inequality. Yeah? That work for everybody? Anybody have a question about that? It's like, in case people don't understand what's happening and you don't want to ask, it's like having A equals B and then we just added a random plus X on it, right?
Wait, no, I did that step right here, and I labeled it as segment addition, but I crossed it out.
You're
Did
like-
our fifth step.
Ah.
I did this step too early.
I see.
Now I have it.
Well, we could have done this here. I mean, that would have been fine. That could have been done.
Yeah, no,
Property
we
of
just need
inequalities.
Now what?
now we have to substitute WS or WT in for WV.
WS in for WV.
On the second half.
What's the left or the right?
The right
Okay.
side of the inequality is WV. Do we need to substitute WT in for it now?
We do. We definitely do.
Okay.
Okay, so let's do this all beautifully, right? Okay, here we go. So, actually, we could save ourselves some trouble and still do addition property. And do that a little bit different.
He was gonna raise
Did you?
it. Yeah, I waited.
Measure of WV plus the measure of VS. Wait, no.
It's SV earlier.
SV, that's what I want, thank you. Which this should have been that, yeah. Great. And then the measure of QT. No, the measure of WV plus the measure of QT. That looks great. Because see, this is already the same now as this. This we just got to turn in WV to WT because they're the same. So the measure of WV plus the measure of SV is greater than the measure of WT plus the measure of QT because substitution. Great. And then what?
The measure of VS is greater than the measure of VQ, or WQ. WS
Yes.
is greater than WQ.
Yeah. I think there's one or two places where we might have cheated a little bit, but we'll count it. This addition property of inequality is a little bit sketchy because it's not a number, but I think it's probably fine.
What is the justification on number 7 say?
Substitution. That S just like had a wild bender last night or something, I don't know. Great. How we doing on time? Where's my, forgot to grab my watch today. We're doing pretty good on time. What other questions do we have? The other proof. Great. Well, I can tell you right now, we're going to do some segment addition. Just looking at it, just looking at that top A, B, C, D part, that should scream segment addition to your brain. I mean, we may not, but looks like segment addition to me. Ooh. Given that AF is greater than DJ and FC is congruent, I don't know what I said. I think I said greater than. Congruent is what I meant. Is congruent to JB and the measure of AB is greater than the measure of DC. And we're supposed to prove that the measure of angle AFC, not to be confused with its more famous cousin, KFC, is greater than the measure of angle DJV. That's one of the dumbest internet hoax, whatever things ever, is the KFC rat. That's stupid. Never happened. It's fake news. There was some, this has been several years ago, there's some picture of what appeared to be a fried rat. And like, oh my gosh, KFC fried a rat. No, they didn't. That's stupid.
What?
I want a fried rat.
Oh,
I would eat rat if I had to. I mean, like, whatever.
I don't know if I'm gonna go to a chicken place to eat a fried rat.
No, I mean, the only way I would eat fried rat would be in like survival situation. Like, I mean, rat wouldn't be my first choice. I mean, there are plenty of more reasonable like things to cook.
Or if someone made
You don't need a fryer.
There's-
You need a pot and oil to fry things.
Did you ever seen Survivor Man? The Cooler Bear Grylls?
The cooler bear grills.
Yeah, he would like actually get dropped off in the wilderness with like a GoPro, and they just like let him do his thing for like.
Are you talking about what's his face? The actually pretty legit guy.
Yeah.
Same starts with an L.
Yeah, I don't remember his real name, but he just went as Survivor.
Bear Grylls is such a hack.
But anyway, there was one Survivor Man episode where he cooked a squirrel. And just like
I mean, sure, like it's reasonable.
You versus Miles.
What should we do now, kids? Let's see. AF is congruent to DJ FC. So these one is congruent to these one. And AB, this is greater than this. Okay, great. So, what now?
How many steps more was it?
BC is equal to CB.
This is greater than this. E's, what did you say?
BC is greater. The measure of BC is equal to the measure of CB.
Sure. It's fine, but I would have done this one first, but that's fine.
What's that?
Like giving us those angles. Oh, it doesn't actually give us those angles yet. Just kidding. We can't do that one. We can't do anything with that until we do what you're doing. Okay, great. The measure of BC equals, well, sure, well, fine. CB, because reflexive property. Great.
Now we can use that sketchy property again.
I think we're gonna definitely use segment addition this time, which we didn't really use when we kind of did last time. And do some direct substituting probably. Right?
We can't just.
We need AC is greater than DB. Yeah, that's what we need.
Yeah, can we use that addition of inequalities property again? And skip 10 steps?
I don't know, man. What do you want? You're wanting to add what?
A, B, and BC on one side, and DC and CB on the other side.
I'm not sure that's actually going to help you as much on this particular one.
Isn't that just going to give us AC is greater than BC?
No. How would it do that?
Because we already have AB is greater than DC, and we're adding AB plus BC is greater than DC plus CB, so then we get the long side.
It's going to give you, it's going to, like, you would do subtraction and you end up right back where you started
Why would we
without the
subtract?
segment.
Why would we subtraction?
Like, okay, so where you're headed, where you're saying is to head to AB plus the measure of BC is greater than the measure of DC is plus the measure of BC ultimately, yeah? That's, and then
go to AC is greater than DC,
what on earth tells us that? Just from there?
right?
No, sir. Where?
We're adding terms.
Yeah, what
Oh.
what do we need to get there? Yeah. You can't just magic it.
You can't just add stuff.
No. So, let's do segment addition real quick. Are you sure about that? AB plus the measure of BC equals the measure of AC, and the measure of DC plus the measure of CB equals the measure of DB, because segment addition. All true and reasonable. Technically, by the way, we cheated. I chuckled about it and kind of mumbled it, but like, we can't just like say that, right? We have to say they're congruent and then they say they're equal. Their measures are equal. Just we kind of cheated a little. Just so y'all are aware that your dirty, rotten cheaters will continue on.
Wow.
Wow. We skipped a little step of definition. Now can we
I'm so tired. I'm your classmate.
I said too tired, not so tired.
Okay. Hi, too tired. I'm your classmate.
I stayed up last night.
Tired classmate.
And are you sure you want to read Warriors? No, I was not reading Warriors last night.
Last night.
She didn't say anything about the night before last.
What did we do there? Oh,
Is that the
addition property, yeah. And on this particular problem, that's the same thing that the book does.
I don't remember.
Well, it was way back at the beginning, like with just like real like, well, I say that it was maybe even back as far as like the review chapter, which we didn't do, but so you learned it in Algebra 1, assuming you had a proper Algebra 1 class. You learned like addition property and identity and all those things like ages ago. Now what can we do?
Now can we substitute?
Yeah, we can.
And then we can have the answer.
So the measure of AC is greater than the measure of segment DB, because substitution. Now what?
Now we can use the Hinge theorem.
No, the converse of the Hinge theorem, but measure of angle AFC is greater than the measure of angle DJB because of the converse of the Hinge theorem.
You need to work on your B's and your sixes.
You need to work on your mouth.
You need to work on your Warrior Cats edition.
This is an intervention, Holland. Get used to it.
Yeah, stop that.
I'm addicted to mini shows and stuff. Warrior
To many shows and stuff.
Any shows,
Very descriptive.
Warrior Cats is not one of them.
Okay, any other quick questions before we quit?
What's your favorite thing on the Chick-fil-A menu?
It depends on the day, but the worst thing on the Chick-fil-A menu is the wraps. They're not very good.
I've never had one and I don't plan on having one. The kale crunch salad.
I quite like, it's pretty good. I quite like the deluxe chicken sandwich.
Okay,
It's
American
quite good.
Colby Jack or Pepper Jack?
American, of course.
Okay.
Of
I'm not one
course.
those people.
I like pepper jack. Pepper jack's great. And Colby Jack is like a fine cheese. It's kind of mild and boring, but on that particular sandwich, American is definitely the best. On the spicy one, the American is also the best.